Good morning, all of you. We were doing elevation in boiling point. Water boils at 100 degrees Celsius. If some solute is dissolved in that water, then that water will be boiling at a higher temperature. Means there is an elevation in boiling point. Elevation in boiling point, that is delta TB. Yesterday I told you 100 degrees Celsius is the boiling point of water. Suppose you add a little bit of impurities or solute or salt in that. Suppose it boiled at 102 degrees Celsius. Then that elevation in boiling point, that is delta TB, is 2, which is proportional to molality, the quantity of the salt, your solute, or that impurity dissolved in that. Delta TB is proportional to M, or delta TB is equal to Kb dot m, where Kb is called molal elevation constant or a bulioscopic constant or boiling point constant. So let's see that equation. Delta Tb is proportional to m, that is molality. Delta TB is equal to Kb dot m. What is m? M is molality. Kb is the molal elevation constant. Molal elevation constant or a bulioscopic constant. A bulioscopic constant. Or boiling point constant. Boiling point constant. Delta TB is equal to Kb. Kb into. Now molality. Molality is Wb upon Mb whole divided by Wa upon 1000. So using this, the main use of this is to find out the molar mass of an unknown solute, that is Mb. Delta Tb you can find out by the experiment. Kb will be given to you. Wb you are taking. Wa you are taking. So Mb you can find out. So this is utilized to find out the molar mass of the solute. All are in grams. Mb grams per mole, W grams. So from there it is number of moles, Wb grams, Wa grams, and delta Tb. This is capital T, Kelvin scale. Whether it is Kelvin scale or degree Celsius scale, the difference is the same. Difference is the same, and difference is a positive quantity. This is the difference. It is a positive quantity. When we do the numerical, we'll come to know that. Now, next is depression in freezing point. Depression in freezing point. Now, what is the definition of freezing point? Freezing point of a substance is defined as the temperature at which vapor pressure of a substance in liquid phase and in solid phase become equal. So, freezing point means the vapor pressure, both the vapor pressure when it becomes equal, vapor pressure of a substance in liquid phase and in solid phase become equal. Vapor pressure on y-axis and temperature, Kelvin scale, temperature T on x-axis. This is 1 atm. On the top it is 1 atm. Atmospheric pressure 1 atm. Now you consider liquid water and solid water. Liquid water, this is water is a substance. Vapor pressure of the substance in liquid phase and solid phase become equal. Liquid water and solid water. Solid water means ice. So I am drawing that as in the case of yesterday, I am drawing means as you heat the vapor pressure will become equivalent and equal and finally it will touch the atmospheric pressure line as you increase the temperature. When you decrease the temperature, the vapor pressure is decreasing. When you decrease the temperature, the vapor pressure is decreasing. So this is pure solvent. Pure solvent means I'll be writing here solvent, liquid water. In the case of water, that is liquid water. Now, vapor pressure of the solid solvent, that is ice. Vapor pressure of the solid solvent, that is ice. This is the line for that. This is solid solvent. Now, what about the solution? What about the solution? Solution will be having lower vapor pressure as compared to the solvent. That yesterday also we saw. So here, the solution line I am drawing, the solution line is always having a lower vapor pressure and the solution will freeze. The solution will freeze when the vapor pressure of the solution becomes equal to the vapor pressure of pure solvent. This is the pure solvent. This is the pure solvent. Solution will freeze when its vapor pressure. Solvent will freeze when its vapor pressure becomes equal to the vapor pressure of the solid solvent. If it is liquid water, solid solvent is ice. A solution will freeze when its vapor pressure will be matching with the vapor pressure of the solid solvent. Now, what is the freezing point of pure solvent? Freezing point of pure solvent is this, I can write it as T naught F, pure solvent. And the next one, that is TF. So which is greater? T naught F. T naught F is greater. So what is the difference? What is the difference? That is T naught F minus TF. This is TF. T naught F minus TF. So T naught F, that is higher. Difference means is always positive. Higher minus lower. T naught F minus TF. Whether it is in Kelvin scale or degree Celsius scale, this is same in degree Celsius scale as well as in Kelvin scale, and it is a positive quantity which is proportional to again molality. So delta TF is proportional to molality, or delta TF is equal to KF into molality. KF is called freezing point constant or cryoscopic constant. Cryoscopic constant or freezing point constant or molal depression constant. Now, delta TF, let me expand that. Delta TF is equal to KF dot. Again, molality, we will be writing WB upon MB divided by WA upon 1000. This experiment is done at what temperature? The freezing point. Freezing point means you have to lower the temperature so that the vapor pressure decreases. In the case of elevation in boiling point, you have to go to a higher temperature. That is again a disadvantage. You have to go to a higher temperature in the case of elevation in boiling point. In the case of depression freezing point, you have to come down to a lower freezing point, lower temperature. So these two things are disadvantages in these experiments. One is at a very high temperature and one is at a very low temperature, 0 degrees Celsius. Making a 0 degrees Celsius in the laboratory for experimental purposes, it's a difficult process. Now, here again, we are using this equation to find out the molar mass. Means again, this delta T, it is in your hand because T naught F, first you find out this T naught F, then you add a certain amount of solute in that, this WB that is in your hand. Again you, means after making the solution, again you find out delta, this TF. Then the difference you will be taking, this is a positive quantity because higher minus lower, this is higher, this is lower. WA, that you are taking the amount of solvent you are taking, the amount of solute you are taking. KF constant will be given. KF constant, KF and KB, that is for the solvent. KF and KB for the solvent. KH was for a gas. So using these equations, we'll be doing the numericals. Mainly these equations, delta TB and delta TF, both are used to find out the molar mass of the solute. Molar mass of the solute. Let's do a few numericals based on this. Question: 18 gram of glucose. 18 gram of glucose. That is C6H12O6 is dissolved in 1 kg of water, 1 kg of water in a saucepan. At what temperature? At what temperature will the solution boil? Will the solution boil? At 1.013 bar. Kb for water. See, this is solvent for water. Kb for water. This is a constant for water. Maybe other solvent like benzene, so it has got another Kb. Kb for water is 0.52 kg per mole. So at what temperature will the solution boil? That is TB. Sorry, yes, TB. TB you have to find out. TB is higher, T naught B is lower. But in the case of freezing point, this is in the opposite way. That is T naught F minus TF. Here it is TB. TB is higher, T naught B is lower. TB minus T naught B is equal to KB into WB upon MB divided by WA upon 1000. Here T naught B, this is water. So it is boiling point. Boiling point means 373.15. This value is 373, capital T, 0.15 Kelvin. 373.15 Kelvin is equal to Kb, that is 0.52 into WB, 18 gram. So 18 divided by MB, that is 180. Easy calculation numbers only will be given to you. Dissolved in 1 kg of water, it is already given in kg. It is already given in kg. So this will be equal to, so TB minus, this will be equal to 0.052 Kelvin. So TB is equal to 373.15 plus 0.052 is equal to 373.202 Kelvin. This is TB. This is a higher temperature as compared to T naught B. Slightly higher temperature. Now, next question. The boiling point of benzene. The boiling point of benzene is 353.23 Kelvin when 1.8 gram of a non-volatile non-volatile solute, non-volatile solute was dissolved in 90 gram of benzene. So benzene is the solvent here. So it has got a Kb value or Kf value. Benzene, the boiling point is raised to the boiling point is raised to 354.11 Kelvin. Calculate the molar mass of the solute. Calculate the molar mass of the solute. Now Kb for the solvent. Which is the solvent here? Benzene. It is better to by heart this Kb for water and Kb for benzene. Kb for benzene is equal to 2.53 kg per mole. So here again, this is elevation boiling point. So we are using Tb minus T naught B is equal to Kb dot M. Tb, that is 354.11 minus 353.23. See, boiling point is raised. This is boiling point is raised to this much. Boiling point of pure benzene is this much, that is T naught B. That T naught B we are writing Tb, we are writing here 354.11 is equal to, what is Kb? That is 2.53 kg per mole. I am writing the unit also here, kg per mole. Let's see how the cancellation goes. Into 1.8 gram, 1.8 gram upon molar mass. Calculate the molar mass of the solute. So that is Mb. Now WB that is 90 gram. So 90 gram means 90 upon 1000, 19 upon 1000 kilogram. So what all things will get cancelled? So here this is difference. Here the difference will be in Kelvin. Here the difference is in Kelvin. So the cuttings will be going like this. Kelvin, Kelvin will get cancelled. Kg, Kg will get cancelled. What remains is grams per mole. Of course, MB unit is grams per mole. So MB is equal to, you do the calculation, answer will be 58 and the unit will be grams per mole. So this way you have to proceed. All the other units will get cancelled except what is required. We are calculating for MB. So you will be getting the unit as grams per mole. Next we are moving to depression in freezing point numericals. Question. 1 gram of a non-volatile, non-electrolyte. 1 gram of a non-electrolyte. Non-electrolyte means on dissolution in water, it will not be getting converted to plus minus signs. Means one molecule you are putting, that will be remaining as one molecule only. If you are putting NaCl, then that one NaCl will be getting converted into two particles, that is Na plus and Cl minus. Okay, 1 gram of a non-electrolyte dissolved in 50 gram of benzene. 50 gram of benzene lowered the freezing point. Lowered the freezing point by, see the difference, by 0.4 K means that is the difference. Lowered by 0.4 Kelvin. So you don't have to find out the difference. Delta TF is already given. The freezing point depression constant. The freezing point depression constant. The freezing point different constant of benzene is, this is again a constant, 5.12 kg per mole. Find the molar mass of the solute. Find the molar mass of the solute. Now T naught F, this is a bigger quantity, upon TF is equal to 5.12 into, this is kg per mole, 1 gram, so 1 divided by molar mass, then WA. What is WA? 50 grams. WA is 50 grams. 50. So here I am putting 1000. Alright. So here MB you have to calculate. T naught F minus TF. This T naught F minus TF. This is already given directly, that is 0.4. So 0.4 is equal to 5.12 into 1 by MB into 50. Now 1000 is on the numerator. So MB you will be getting as, all are in grams, this weight WB in grams, then kg per mole, all these things will get cancelled. Finally, you'll be getting it as 256 grams per mole. 256 grams per mole. So mainly, this is used to find out the molar mass of the solute. Now you see in degrees Celsius, here it is given 0.4 Kelvin. The difference is directly given. You know that water boils at 0 degrees Celsius, and suppose the solution, water freezes at 0 degrees Celsius. Water freezes at 0 degrees Celsius. Suppose the solution is freezing at minus 10 degrees Celsius. Now what is the difference? 0. This is the freezing point. That is 0 minus minus 10. So this is plus 10. So the difference is always positive, whether it is degree Celsius or in Kelvin scale. This difference is always positive, that is higher minus lower. Bigger minus smaller. The 0 degree Celsius means I can write it in the form, that is 0 degree Celsius, that is 273.15 Kelvin. Now minus 10 degree means then 263.15 Kelvin. 263.15 Kelvin. So 0 minus minus 10 in Kelvin scale I can write 273 273.15 minus 263.15. So again in Kelvin scale it is plus 10 only. So whether it is in Kelvin scale or Celsius scale, whether it is in Kelvin scale or Celsius scale, the difference is the same. Here, suppose they are asking to find out the uh, freezing point of the solution. Freezing point of the solution. Then you have to write here only the Kelvin scale temperature. This is capital T, this is capital T, Kelvin scale temperature. If the difference is to be substituted, then you can either take in degree Celsius scale or in Kelvin scale. It is better to use always Kelvin scale because sometimes they ask for this freezing point of this solution or boiling point of the solution. So you always write in Kelvin scale only. So there will not be any mistake while doing this numerical. So that's about today's class. Thank you.